And if people don't mind, maybe we just do quick intros with like everyone's like name and where you're from and what you work on. So I can start. I'm Sky. I'm on the JAX team and along with GA at PJRT.
Cool, I'm Jane from Google and working on PJRT, the interface between framework and the hardware.
Shafiq with Amazon AWS.
Jason Verbeck. I work at AMD, kind of own the XLA among a few other things for our data center GPUs.
I'm Wen, also from AMD. I'm working on XLA.
I'm Tejas from NVIDIA. I'm product manager for DAX and Excel.
I'm Tobias, also from AWS. I'm working on the compiler stack for Cranium and Inferentia.
I'm Henpon from Google. I work on XLA CPU.
This is Amin from Intel. I work for Excel CPU optimization for Intel architectures.
There is Mateo. I work at Tesla. We're just investigating whether to get married to SLA.
I'm Alexander Ibovarov. I'm from AWS, working on a compiler frontend, which is excellent.
All right, we'll get started. Yeah, so let's get started.
Oh, so yeah, this is like, especially because some people are having internet trouble, like this is mostly a presentation, but there's lots of code links in it, or when you do get internet. And sort of the goal, even though it's a presentation, we want it to be really interactive, so feel free to interrupt, ask questions, point out problems. And the goal of this is you should feel prepared after this presentation that like you know how to get started and like have what you need to actually write for your.
Cool. So I will first give some high-level overview of what PJRT is, and then go over into the details and look at some code and interactive commands. So what is a PJRT? There are two important concepts. The first one is PJRT C API. This is the device compiler and runtime interface. It is interface between the framework and the hardware. With this C API, we hope that the framework can be device agnostic, just focus on logics that are not specific to any hardware. And then it can switch, it can be cross-platform. It can be easily switching between one backend to another. And with this interface, we hope that the hardware will just focus on implementing the C API, this set of C APIs, and then it can be portable between different frameworks. And the second concept is PJRT plugin. The PJRT plugin is a Python package that contains an SL file, which implements the PJRT C APIs, as well as some Python methods to make it discoverable by the framework. And we have a few examples of the PJRT plugins already. The Apple Metal plugin, CUDA plugin, Intel GPU plugin, the TPU plugin. And in the diagram here, it's a very simplified version, and it's only showing one framework and one plugin. And so here, JAX, representing the framework, will call through the PJRT C APIs to reach the PJRT plugins. And the PJRT plugins will do the hard work for compiling, execution, transfer, etc. And in these many C API calls, some will involve the stable HLO. And then, sorry, I just realized that I didn't present. And then what do we need to implement for PJRT plugin? The first one is compile from a program to an executable. And the second one is to execute with this executable input argument and generate the results. And the third category is memory management, such as host to device, device to host, device to device transfers, and also any buffer management that you want to do for your hardware. And the next category is the topology information, such as what's the platform info, how many accelerators are there, etc. And lastly is the piece to actually register this plugin so that JAX can discover it. So these are the high-level overviews. Any questions?
How it's different from in XLA you have GPU, compiler, CPU? compiler which are not part of PJRT.
So,
So this PJRT is yet another GPU compiler, or is it some sort of interface adapter?
right. So PJRT is just the interface itself. And inside the PJRT implementations, you could be using a GPU XLA compiler, for example. So PJRT is just an interface. It's the interface between these two, and then the actual implementation could involve how you want to do the compiler, how you want to do the execution, etc.
So this is like literally how frameworks target multiple platforms. There's like a GPU plugin and like a TPU plugin, and those contain.
I think it says CUDA plugin, not GPU.
Yeah, sorry.
So it's CUDA specific, right?
Yeah, but yeah, there could be multiple GPU plugins for different GPU platforms.
Is it possible to create a PJRT plugin?
Yeah, you can actually do whatever you want, as long as it
Basically, like any backend can be plugged into.
Yeah, it's like a relatively high level API. So it's like IO execute, and so like how would we do that?
Is there an attempt done to ensure that the interface remains hardware agnostic?
Yes. Yeah, we really do strive to do that.
And are you versioning that, like just like stable and shallow? Like
Yeah, we will have a slide on that.
Okay.
Yeah. Yeah, and also on like an extension mechanism. So if there is something that is hardware specific, there's like a way to touch that.
And then in the following of this presentation, we'll walk through the integration step, and then look at a CPU plugin as an example. So the main task, so now I'm going to dive into some more details. The main task to implement the PJRT plugin is to implement an XML file that contains a method called getPJRT_API, which will return a pointer to this PJRT API struct. And this is a C struct that contains the implementation of all PJRT APIs. The first field is for compatibility, struct size, and then we have a entry point to extension. And then we have the version, which contains a major and minor version. And then the remaining will be all pointers to the implementation of your C APIs. Let's look at one of the PJRT compile C API as an example. So here is the PJRT compile API. We use a type def to avoid lots of function symbols. And then the method always return a PJRT error. This is also a data type that controlled implemented by the plugin. We combine all the input and output inside this PJRT compile args, and therefore any adding new fields would be easier for the API compatibility. So here are the PJRT compile args. Again, it has a struct size for compat, and then it has an entry point for extension. And then for compilation, we also, one of the args is topology. And then there's a PJRT program. It can be a stable HLO, or it can be other types. And we have a serialized compile option and client, and also the output will be this PJRT executable. And we will in the comments we'll indicate the lifetime and ownership of these fields, and also whether a field is an output.
Yeah, by the way, if you want to like follow along, you do it. Like if you go to the openxla/xla GitHub repo, yeah, it will show up. And then open PJRTC API.h. See I see the full API.
Are there any existing plugins there too? Just look at it. I thought that there were some there in the past. But
Yeah, we're going to go over like an
Okay.
example and you can actually build it on yourself.
Yeah, and also it's in the same folder, in this XLA PJRTC folder. And here we have the CPU plugin, and this is the CUDA one.
Okay. So,
Yeah, we have slides going over it.
Yep. Any questions for the how we describe the C APIs?
We'd like another slide talking about compile.
Yeah, don't worry.
Yeah, okay, just something like this is like both a demonstration, like all the APIs sort of follow this pattern, like API compatibility and stuff. Compile is actually a very special API. It's like a really load-bearing API. And especially because PJRT tries to be this high-level compiler runtime API that's actually agnostic to the compiler. So like you can see we have this generic PJRT program. It actually supports like, basically just takes like a string and then like an arbitrary format specifier. So like in theory, you can plug whatever compiler you want into PJRT with whatever input IR you want. However, it's like if you're using, plugging into like JAX or PyTorch XLA, they are going to emit stable HLO, right? So the kind of compile contract itself is sort of like a mini contract that's not covered by PJRT itself. And this is where things like stable HLO, like they have their own compatibility contract and all that. And yeah, especially with things like the compile options. So that's actually a serialized protobuf. And this is sort of like what XLA currently expects. It's sort of like a side payload of important metadata for compilation. So yeah, when you're authoring your plugin, like PJRT is sort of like, you definitely have to implement that, but then you also sort of have to separately negotiate like what these frameworks are actually emitting and are expecting and what the semantics are. So we could try to answer questions about that. We're more PJRT experts than like stable HLO experts, but yeah, they are like we kind of separate them out the APIs, but in practice as a plugin author, like you need to or upstream changes to the frameworks to do something else.
So if I want to implement my own plugin, I need to implement PJRT compile function.
Yes.
And I assume that inside the args it will be PJRT program pointer, which points me to say stable HLO in some sort of a form. Right?
Yeah, like serialized stable HLO.
Right.
Yeah.
Okay.
So you say that it has to be in protobuf, and then we have noticed that protobuf has a limit of 2 GB, and sometimes the stable HLO, if the constants is embedded inside the stable HLO, then
I think stable HLO has its own serialization format, if I'm not mistaken. It doesn't use protobuf. Yeah, so just the compile options are a protobuf.
Oh,
they're small. Yeah.
I see.
Yes.
Bytecode. It's just bytecode.
Okay.
Yeah.
Thanks.
Yeah, no, that would be a problem. And yeah, we actually sort of have like a long-term idea. Like we think we can get rid of the compile options photo by like inlining it all directly into the MLIR module, like a mix of stable HLO and then like kind of other metadata that these frameworks are emitting. So yeah, if this is like really painful, let us know and we can try to prioritize that kind of work.
Cool. And then there are two options to implement the PJRT API. The first one is to implement the C APIs directly. And the second one is to implement C++ PJRT client and then use the wrapper methods that we provided. The benefit is that you can work on C++ instead of C, but you do need to set up Bazel and pull in all the dependency and the helper methods. So here, this diagram shows that in the JAX, there is a C++ to C wrapper to wrap the C++ code to the C API calls. And then in the PJRT plugin, if you implement a C++ client, we have all the wrapper and helper methods to forward all the C calls to the C++ calls. But we do want to mention that the C++ PJRT client interface is not one-to-one mapping with the PJRT C API, because we intend to maintain a smaller and more stable PJRT C API interface.
Yeah, so it means like you don't have to implement the entire C++ interface, and we have slides for figuring out like what you actually do. Because there's some like fancy methods in there that are basically used for other applications, but like not used by JAX or PyTorch XLA right now.
So here is the CPU plugin example. The TFRT CPU client implement PJRT client, the C++ one, and then you need to implement a client create method, which will create the C++ client and then call the helper method to wrap it. And then we also have a helper method to create a PJRT API based on this client create method. And then for all the remaining C API calls, you will just wrap it and call the C++ client result. So basically, you just need to implement C++1 and the client create method, and then implement this method with the helper function. And that should return the PJRT API that the framework needs. Any questions? I'll move on to show the examples. And then you also need to set up the basal build rule. And here's the .sl file. We saw how to start linking and what symbols you are gonna expose. And with that, this is some comments. This will be we will share later as well. Then you can try it out to see for the CPU plugin example. Here, like you can first clone the XLA repo, and then we have a branch that has our vlog, and then you can run basal build, which will build SL file. You can check what method are exposed, and you will see that sorry, the output was not printed here, but it will have a noise here. The get PJRT API method, and then we can install JAX and run JAX with this plugin. For developers, we have an environmental variable that can help you to set a JAX to use the plugin, so that you don't need to do the Python packaging immediately while you're still developing, working on the implementations. So this is the environmental variable. It will be a key value pair with the plugin name and the path to the SL file. We have different environmental variable, which is to enable the compatibility. Right now, the default is require the framework and plugin to have the same version, PJRT CAPI version. But setting this variable can relax that. And we do intend to change the default to be supported compatible. And the other environmental variables to show the logging. And after that, you import JAX. And then if you get the client, then it will show that it's a CPU plugin. And then if you call backend PJRT CAPI version, it will show that it's the version that this plugin was built.
And we're going to cover like the version compatibility.
And then now I'll go over a few APIs. The first one is devices. So this is a JAX API. And if you call this API, it will show that there are 4. So this devices is configured by the plugin. We will have 4 devices, and this JAX API will call the client device C API, and if you are doing a C++1, then it will be the devices. In the CPU plugin, the devices are created when the client is created. And there are a few main data types in PJRT API: client, device, buffer for the data, executable and loaded executable. That's for AOT. And there's a PJRT event to support asynchronous operations. We also have a device description and topology description for the topology and for support AOT.
That's like ahead of time compilation, like so you can compile without like the actual.
And so now we can move on to the data transfer APIs. If you call the JAX API device put, it will transfer the data from host to device. And you will call the C API buffer from host buffer, which also corresponds to C++ API here. And if you call device get, it will transfer the data from device to host, and calling the C API to host buffer and the C++ API to as well. And for doing compile, when you do the lower compile and then executable, you will call the compile C API that we showed earlier. And then if you run as text, you will further to get the optimized program from the executable. So the compile will return an executable. But if you call the as text, you will call optimized program which will return the HL modules.
Yeah, so this is like technically optional, by the way, like if a compiler doesn't actually produce HLO at the end of the day. I think right now, like JAX does, I work on JAX, by the way, so I can't really speak to like PyTorch XLA or TensorFlow, but like JAX does, I think, sometimes use the HLO module for things like getting GSPMD shardings. Like hopefully on your plugin authorship journey, like you won't kind of hit that kind of thing until much later. That we should like reach out to us after that if you're trying to support that kind of feature.
Yeah, so like I encourage that when you're implementing this PJRT API, that you can start from the very minimal implementation and then go through like try out these different JAX API calls to see like what C API or what C++ APIs are being used and implement those APIs. And these are the more complete start from a JAX 1+1, a JIT, and then PMAP. So let me switch to the terminal just to run a few. So I already built an SO file locally in the VM, and then this is the command I mentioned earlier, which will let JAX know the plugin name and the SO file path. Run it and projects. So this will create a client, and you can see that it shows that the CPU plugin is being used, and then I enable some vlog so that what C APIs are being called, and this one is what's done in the JAX framework. So here are the few C APIs being called, and we can check the first check just to check the C API version, because this is very simple, just 2 numbers. To verify that you are using the plugin, and then you've got at least some basic information propagated back to the framework. And then you can do the client of devices, which you will call the description, and then show a printout here. And let me see, let me do one. Let me do a transfer. So you can see the buffer from host buffer is being called, and this is the C++ vlog, and then it will show that this is C++ message being called. And let me also show JAX 1+1. And then, so this is JAX 1+1. You can see that so the data transfer, and then compile, and then the load the executable, and the executable.
Are called optimized.
Yeah.
Oh, okay, that's interesting.
Yeah. And then finally, you do the execution, the load the executable execute, and then return the value. Now I will switch back to the presentation.
Yeah, I guess this is making me realize that like JAX was originally written like on top of XLA, right? And we're sort of like adding this plugin interface after the fact. So like, yeah, this optimized program is making me realize that we are probably making XLA specific assumptions in lots of places. And so I think there's like a bit of attention here. Like some things like, jax.jit, if you support multiple devices, it assumes GSPMT is implemented. It's hard to work around that. For things like assuming like an HLO program, like usually that's just to get metadata that hasn't been plumbed through the PJRT API because we consider it kind of compiler specific, like how to specify array sharding. So yeah, reach out to us if you ever hit something where you're like, this is like impossible to implement or like really unwieldy. We're open to like trying to make things more generic where it's sort of just like a historical artifact.
So
Speaking of history, just a quick question. Speaking of history, there's like the old way before the plugin of it's like the XLA client path, I think, is kind of more hard coded, right? Is there a deprecation timeline for all that? Like, obviously, want that only worked for like NVIDIA back. It worked for us as well. We still use that in a lot of our builds, but moving to the plugin, I was wondering about like timelines of deprecation of all the old
Yeah,
paths.
so we're not actually deprecating like XLA client.py, I think you're referring to.
Yeah.
That's basically like, maybe the name should change, but like we're sort of still using that Python module, but like adding generic plugin functionality into it.
Okay.
So yeah, I mean, like we already like TPU is already, it also has historical baggage. Like that's a plugin where like really close. Like we have like a CUDA plugin that used to be just statically linked into JaxLib. We're breaking it out into a plugin. We're just like fixing like a few last bugs before flipping that in the default and getting rid of the statically linked build. So it's like plugins work. And yeah, we sort of like retrofitted the existing Jax
So
machinery.
that's kind of the plan. I'm interested because we'll, on the AMD back end, we mostly kind of do the same thing as the video stuff, but we want to make sure that everything isn't, or like things kind of switch over entirely to have like this separate library that's built and all that kind of nice.
Yeah, I mean, so that's like why we sort of switch over the GPU to be a plugin or the CUDA GPU plugin because like it already worked. We didn't have to do that, but like we wanted both it like actually cleans up the build and a lot of things is nice, but like also to make sure that this actually works. So especially for you guys, it's like that is probably the plugins look very similar.
Yeah,
that should just work.
Yeah.
The only thing that's missing right now is like. In fact, it might not have just been fixed. But like, yeah, there was like a few PJRT APIs needed by DL pack support, like weren't fully there. So we couldn't flip it over by default. It would be a regression. But like, and I think like the next release we do, like it actually should.
Okay. Yeah. Cool. Yeah. We can talk maybe a bit more later on politics, but that's good to know.
Yeah.
Yeah, so one common question is which APIs are required to implement a PJRT plugin. So we plan to move the optional CAPIs to extensions, which will take some time. Meanwhile, we will add comments to indicate whether an API is optional or required. And another way to do it is that you can let your plugin returns are implemented in most of the methods, and then run the JAX code I showed earlier, like how to run some JAX code and then check whether a certain method is implemented, which methods are being called, and then whether you need to implement it.
Oh, then once you get like basically like JIT, PNAP working, the JAX unit tests are actually like really, really good coverage. Well, too much coverage. That's why we sort of need to like indicate which things are optional.
Yeah. And also like optional is still subjective, so it depends on the user.
Yeah, so it's like, like all optional features, at least right now, like can be targeted by a JAX, like and a high context array. But we're trying to give some idea of like what is the core functionality that is reasonably needed for any workload, like say JIT probably needs to work. Everything else, like, it might be something that the user can live with or without, depending on their workload. So like, having the ability to like do Python callbacks from compiled code, like we consider that an optional feature, but some people might be using that to export metrics or something. And they'll need it.
And then other than the C++ or the C implementations, you also need to set up the PJRT plugin as a Python package by putting it in the JAX plugin directory or set an entry point so that the JAX framework can discover your plugin. And you also need to implement the Python initialize method, which calls the register plugin, and JAX will call this method after it discovers the plugin. And you can pass on your specific options here if there's anything you create option needed for a plugin. Okay, so now let's talk about the API compatibility. PJRT API has a major version and a minor version. For the case that the framework is newer than the plugin, for a minor version update, the framework will provide an early forwards compatibility window that will start with 6 weeks. And then for major version update, it will be a coordinate update because it's breaking the API compatibility.
Oh, yeah, and this is just API compatibility, by the way. So it's like the builds won't break, but like we do reserve the right to like make like source compatibility breaking changes, like we might change variable things. So sorry. Let us know if it's a problem.
And for the case that the plugin is newer than the framework, it will be the plugin defines their own behavior, how they want to do their backwards compatibility policy. And right now, this compat is not enabled yet. You can set the environment variable to enable it, and we will turn this on in the near future. Now I'm going to cover like 2 advanced features. The first one is the extension. Extension is useful for optional or experimental features, and there's no compatibility guarantee for this extension related to. Then it will be a separate contract from the PJRT APIs. And each extension is extending this PJRT extension base, and then you will have a pointer to go to the next extension. So it will be a chain of extensions. The entry point can be either the PJRT API, like the main C struct, meaning that you can have extension to have your own C API methods, or it can be in the arguments, meaning that you can have like an optional field in the arguments through the extension mechanism. And to add an extension, so first you need to add a type to the PJRT API, such as for example, here's a GPU custom call, and this change we need to touch the PJRT API, and but for the second step, to implement your own extension, this will be a totally separate file, and you have like control over it. The caller, like framework, will still need to know about this with any specific feature, such as a custom call in the JAX custom call code. Then you need to know about this extension.
Yeah, so we're like planning to, for instance, put optional features as extensions, which means that like we might want to implement our extensions. We probably like will like still like do API the same forward API compatibility for that reason. But then there might be like other features, like experimental features that we want to like rev really fast. And so we like don't really recommend implementing those because the API compatibility will be tough. And then, yeah, you can also add your own if you have like hardware specific thing. The tricky part about that is that you do need to like coordinate, you need to upstream the framework changes into the frameworks to actually like discuss extensions. Like if you have PJRT leaves that door open if you can separately negotiate that.
For example, like the custom call and custom partitioner and the profilers, like not all hardware or not all plugins needs to implement these extensions. And the other advanced feature is multi-node support. The framework can pass in key value store callbacks to the plugin as input arguments for the client create method. And JAX already started this mini distributed service and also passing these key value callbacks. So, for example, in the CUDA plugin, we use this key value store callbacks to exchange information between nodes, to know how many other devices other nodes have, and also assigning a global device ID. So you may, if you need to exchange information between nodes, you may want to utilize this callback.
The intent is to kind of like bootstrap like multi-process or multi-host distributed like setups, topologies.
Yeah, so I think this is the end of the presentation. You want to know about any questions you have, what are the pain points.
So all the buffer allocation has to be implemented by the implementation of the client, is it?
Yes.
Yeah. Oh yeah, so the interesting thing about PJRT too is that it has, for the most part, immutable buffer standards. So yeah, I don't even think we expose like the allocate. I don't think we could have a raw allocation method. It's like buffers are sort of created like when you do a HTTP transfer or when you run an executable, and like buffers just come out. But yeah, under the hood, you are responsible for that allocation. There are some exceptions to this, which kind of make Jax's semantics a little crazy, but like not your problem. For instance, we support buffer donation. So like if you're passing an input buffer into a computation, then there's like a compiler feature to indicate that it can be consumed. It's kind of like STD move. And then like DL pack actually, like people might, and who knows what people will do with on buffer.
Thank you.
So, do we have any prerequisites before we start working on PJRT project? Do we need to implement something in XLA itself, like compiler, like for the new device, before we start implementing PJRT? Or it's not necessary. We can just use some existing third-party backend without adding anything to XLA.
I mean, I guess it kind of depends. It's like, yeah, PJRT sort of assumes you like have a compiler at runtime for your platform. So like if you can like reuse XLA in some way, which would probably require like changes to XLA, that's probably easiest. Just because, yeah, like it's very, then you naturally like kind of expose something that looks like XLA, which is what all these frameworks are expecting. But in theory, you can like write your own compiler from scratch as long as it can consume stable HLO and the rest of the file contract. Yeah, because the runtime methods are like fairly not controversial.
Yeah, okay. Yes, I understand for the compilation, but once I compile the model to some sort of binary, and I also have my own custom runtime to execute it, how to integrate the runtime with PJRT.
So it has a bunch of runtime APIs. Yeah, I mean, so like execute is sort of the core of this. Like that's like sort of the beauty of the compiler is that like there's sort of one entry point everything. And then there's actually like a million other methods to like, yeah, do data transfers with the buffers to like get metadata out of like every single one of these types. There's like the topology information, which is also the responsibility of the plugin to say like what kind of configuration are we actually running in, how many devices are available so that the user can configure the compilation basically. Yeah, turns out there's a lot of stuff. But I think it should all be like, I think everything except sort of the compile API is like pretty obvious for a runtime. Maybe I'm wrong because there are a lot of APIs. Yeah, most of the interesting stuff comes around like the compile.
Can you talk about the extension mechanism a little bit more? Like, what would I use that for actually? So you show the profiler. So it's like, do frameworks actually use that mechanism to call these extensions? Or
yeah, I mean, so right, we want to put like optional, like for example, like in Jax right now, we are implementing like giving users control of the on-device memory layout, so that like like prior to this, it's like we'd sort of have like a default layout for like all buffers that like the user has in their hand, and then the compiled executables for to do whatever layouts it wants inside the execution. But sometimes users like, that actually by having like the default layout is nice because that means that like users never need to worry about getting like a mismatched layout for what they compiled for and like what is coming out of their data loader or whatever. Like it's a little one choice. But now we're letting them opt in to like, for performance reasons, like specify the layout. So that is actually, first we started putting it into the main PJRT API. So you'll see layout stuff there. Then we like both at the same time decided that no, this should be an extension because it's like both optional and experimental, like we're still changing it. And we're actually like changing the data type. So like that's an example of like Jax already has code that's like using this layout API, but we're like actively hacking on it. And I don't recommend implementing it until that like stabilizes a little bit. At some point it will stabilize. Then we'll probably still keep it an optional API because it's like, right now might naturally work on all XLA backends. But yeah, like it's the kind of thing we don't expect like every single backend to necessarily support, and users just have to, not do that. So we'll keep it as an extension, and then at that point, like it might make sense for you to implement if that's what your users want. And then for adding your own extensions, that's like way more, then you'll have to like talk to the frame, like talk to us about Jax, not about PJRT.
Right.
Like I think at the PJRT level, the only thing you need to do is sort of register the extension, and we could even like make a generic license for that. But it's like the question is who's actually going to call this extension?
Yeah.
You could even like, depending on the nature of it, you could like create your own Python library that you distribute that are like the client side APIs for calling into this extension if like they don't need to hook into the existing parts of the framework. It's just like runtime information or something. But probably for most features, it's like you need to, the framework needs to be aware of the feature.
Sure.
Yeah.
So for the layout thing specifically, you mentioned, so is the idea there that users will specify the layout for the device, or because you could also sort of query, right? Like you could ask.
Yeah, it's both. And the first thing we're supporting, like the more common case is like, let the compiler, right now it chooses all the interior layouts, but it's like we fix the boundary ones because like the boundary is sort of where it mess things up. Yeah, but now we're like, no, compiler can propagate all the way to the boundaries, and then the user is responsible for like querying the executable and passing that back into like whatever, their init function or like any device post that they're doing.
Okay.
The types of transfer that pipeline was device to device, like how did we find host? Was there one for host to host? Interesting.
That's a good question. Yeah, so we're like sort of assuming this model that I think will always be true, where it's like the Python code is like just running on like the host. And like, yeah, especially for Jax, it's like we're very narrow. Like Jax is really just for running things like on an accelerator, and like CPU is sort of like a funny case of an accelerator. That's usually like plugged into the host. And so, right, like as long as you're sort of like in Jax land or like in PJRT land, like you don't need to transfer anything back to the host. Like, you can like compile one function, run it, like buffer comes out, pass it to a different function, like no transfer needed there. But if users want to print a value or like do anything with the value in Python, like write a checkpoint or like, yeah. And so that's where like the HTTP and DT transfers. Or like similarly, like in Jax, we don't have a data loader. So it's like, and usually the data loader kind of like runs on like your CPU, you can use like NumPy and existing functions or like whatever. And then so you end up with like a NumPy array basically. And then you have to transfer that to the device to actually feed it to the stuff like so yeah, it's like, and then D to D is sort of for like resharding or like we just allow users to do that. And then the host ones are more for like the boundaries, like when now users are coming out of Jax or like out of the framework and want an interface with just like regular Python thing. Right. And that's why we don't have host to host, because that's sort of like there's existing libraries for that. Yeah. You might have like TPU multi-slice configurations. Like the runtime actually does use like host to host communication, right? To like run, but that's sort of all underneath the PJRT. Yeah. So it's like we don't expose that to the other. Good question.
I have a question about graph optimization.
Okay.
I just want to understand how PJRT helps here, because in XLA we have roughly like 180 classes to optimize graphs. Some of them device independent, some of them different. dependent. So when PJRT gives me a stable HLO to compile, is it pretty much non-optimized or some
Yes,
of,
it's like what comes out of like the framework.
okay.
And actually, something that does come up, because like came up in the last session, is that like, yeah, again, because like JAX was built on XLA originally, and that was sort of like the prominent, like what's cool about it is that like it just kind of emits math, like very low level math, like linear algebra operations, and then like the compiler, you know, generates kernels and stuff. So like, but how this comes up as a problem is like JAX doesn't emit like batch norm operations or like softmax operations. So it just emits the math implementing that, and then sort of assumes the compiler is going to figure it out. This doesn't work all the time on any platform. Like people use kernels sometimes. And so kind of like a request we get a lot is like, can't you emit a higher level operations that I don't have to pattern match? Like I can just like splat out the kernel that like the user clearly expressed somewhere higher in the stack. And we don't have a great story for this right now, but if this is a problem for you, it's like, we do have ideas around it. So it's, let us know if it's situation. It's also made complicated because JAX itself, like, I actually learned today that it does some like, you know, it has like a softmax operation, but it like higher level, like a lot of logic is actually not implemented in JAX itself. Like if you're training an LLM, there's libraries built on top of JAX that do that. So we might, some things might actually need to be plumbed through these like higher level libraries like Flax or max text all the way down through JAX. So we sort of need like a generic API for that. Something to keep in mind. But yeah, it's like sort of from the PJRT perspective, like, yeah, we don't help with kernel optimization at all. It's just a conduit for the framework to like pass something into the compiler.
Okay. So the benefits of PJRT plugin is just this integration point.
Exactly.
Basically, to get the model converted to stable HLO and give it to this plugin.
Yeah, like actually,
99% of the XLA is not used at that point, right?
yes.
And I guess when I implemented the plugin for PJRT, the first step I need to do is to take the stable HLO and create some sort of a pass pipeline and start doing hardware investigation optimization. Simplify it.
Exactly.
And like each plugin is going to do that.
Yes.
Pretty much always. Right?
Yeah, yeah. The like the kind of purpose of PJRT is really for frameworks that have like a platform agnostic API, so that they can like, you know, you can plug in all these different hardware platforms like without having to have like custom framework code for each one. But yeah, that's why we kind of like couldn't write the PJRT plugin in this session, because it's like step one is like write a stable HLO compiler or like reuse XLA. It's kind of, you know, it takes more than an hour.
They have like several pass pipelines which
Yeah.
optimizes stable HLO.
Yeah, no, I do think PJRT sort of like buries the lead this way. It's like all you need to do to interface with JAX is implement this API, but then yeah, that one compile call is going to be like a really big API to implement.
Sure.
That's like the million line function. Yeah,
So is it going to be a standalone project in the future?
that's a good question. Yeah, because it is like it should probably be its own repo because like it is compiler agnostic. It's a big pain to make a standalone project. It was just like sort of easier to like reuse the OpenXLA like machinery around that, and yeah, it also like, you know, in practice these frameworks are like emitting stable HLO, so it's like it is, the API is agnostic, but like in practice like there's a lot of XLA dependencies in there. So yeah, we're not planning to pull it out because we just don't think of it.
So if I have PJRT plugin, will it help me to run PyTorch models, TensorFlow models?
PyTorch XLA, yes. I'm not sure what, do you know what's going on?
TensorFlow, you need a little bit a few more CAPI that's specific to TensorFlow, and also how you register it. For the main bulk, it's like a used.
So it's more or less framework agnostic approach. So if I create PJRT plugin, all the frameworks which support XLA.
Right, because we went through the work of making frameworks. Yeah. Oh yeah, another reason too for it to be in a project is like if you are using this connector, like the C to C++ connector, then like you are like building actually huge parts of XLA, but it's like easy. Like if you do want to, you know, if you like don't want to do that, you can just like copy and paste the one C API header file and any of the extensions that you want to implement into your project. So that's why also we don't really feel like we need a different project. It's like the sort of like independent part is like just this tiny amount of header files.
Very basic question. RT stands for runtime. What is the PJ?
Oh, sorry, can you say that again?
The acronym PJRT.
Oh God.
Jim, all right, is it?
I looked it up. But
Yeah. I hate to say this on the recording, but no, it's fine. It's not actually secret, but it's like like this is like PJRT was like literally it was just like the code that Jax used to target different backends.
Okay.
But then I think like there's like pathways at Google, which I think is like there's been a blog post about it, so I can talk about it. Like that also used PJRT, and so they wanted to like move it out of the Jax folder, and they're like, what should we call this API? So it's like pathways to Jax runtime. But it's like now we don't like that. You know, now maybe we should call it like PyTorch Jax runtime. It's like a total acronym at this point. Like that wasn't a thing.
I love it.
Just be pajama runtime.
Pajama runtime is probably best.
For fun.
Yeah. Or like the original API was written by my colleague Peter, so maybe it's like Peter's Jax runtime. But yeah, they're all
That's fine too.
yeah. We could probably have thought about the name more.
I had a further question. Like, so I understand the project at all, PJRT. Will it change how like Jax is delivered? Or because today we have Jax and we have JaxLib. JaxLib's kind of XLA, right? That's built for CUDA, or in our case, for actually. For when we deliver Jax, we have we can get Jax is kind of agnostic. We have our JaxLib that can come to us to get, right? So could it change that? We'll have like Jax and JaxLib, and then you just get back.
Yes, exactly. That's like the primary goal of this project is that like there'll be one platform agnostic JaxLib.
So JaxLib could become device agnostic, and then you just go in with the plugin. That includes like all the CUDA, or in our case, the rock stuff that gets built excellent. Okay.
Yeah, and that's like part of why we're pulling out CUDA into its own plugin, because it's like really like we don't like having all these different JaxLib builds. So hard to install. Yeah.
So that will simplify things from our point of view as well, because when we have our customers go and deploy Jax, they kind of get this other kind of place to get Jax, right? If we could just here's your plugin, go and use it on whatever version of compatible JaxLib. That makes sense.
Exactly. Yeah. No, and I think it's gonna like simplify the install, because right now is like you have all these different JaxLibs. They're all called JaxLib.
Yeah.
Because there's no like discovery mechanism.
Exactly.
It's like very, very yeah. Easy to like
very hard to
install.
deliver. So this should help with that. That's okay. Well, thanks for that.
Yeah.
Question about the so in the backend, if you have like let's say in a heterogeneous architecture, is there any concept of heterogeneity in PJRT synchronization across different devices that are not?
That's a great question. So I don't think anyone's like done that before with Jax or PJRT, but
so I know one thing, like Apple's Method plugin, they do have, I was in that team before. I've worked on it a little bit. They do have an heterogeneous SoC because Apple Silicon has a GPU neural engine, but they have treated it as a single backend, so you don't know.
Right. So yeah, I think actually the PJRT interface and even Jax's APIs are generic enough to support this. Like it would basically look like you return all these devices, and that's kind of like how the topology is represented. We actually want to move to like a topology object that has devices, so you can like also put more metadata that's like not specific to the device, which might help. But then yeah, I think you can just have like and the devices are sort of like we leave some kind of like entry point, or what do you call it? Some vagueness there. I'm not using the right word, but it's like you have a lot of freedom in like what you stuff into a device object. Like because we know that devices are very platform specific, so we try to make that easy. So yeah, you could just return like devices, and this would be platform specific to you. That like, oh no, actually we already have like APIs called like device kind. So like you can like return different types of devices from one topology, and then users would like see those devices. They'd like see whatever metadata you're providing for them to like distinguish the devices and understand what they mean. And then they are free, then it kind of has to work within JAX's existing APIs to like put together a computation. Like we might need the mesh might be like kind of limiting here, but like basically if you can like stuff it into an XLA device assignment, and like then it will just get like passed through. That will get passed through the compile call, and then you're free to do whatever you want on the compiler runtime side. So I think this can work. The JAX APIs probably can express this right now. It might be like a little bit awkward, but possible. And that, I would start with that, and then depending on, maybe we can work together on more like ergonomic end user APIs. But I think PJRT Stack should be fine. Except, maybe modulo some like weird but we need like a like compile API might be a little weird. I think you can sell it through. Yeah. That'll be cool. Let us know if you do that. I would love to see that. And I guess we're starting like with TPU, we're like starting to like, host offload is actually an example of this. So we're like, we're even JAX, we're like starting to develop new APIs to support heterogeneity. But they're nascent. They're experimental.
So you're saying that TPU, Google TPU is the same PJRT for Git interface?
Yes. No, that was actually
Like, it's not open source.
That plugin is not open source, but the interface is. That was actually like a big motivating factor for like the PJRT API too. It was like we need this for. So like that's how it kind of works. Like it's like that was sort of like our guinea pig plugin was to make Cloud TPU work.
The thought of where if there's custom plugins that need to be made, like with the GPU one's kind of entry, TPU one's closed source somewhere. So is that like a central place? Like would someone like for us it's easier, but maybe we want to have a custom version at some point. Is there like a repo somewhere that people would post plugins to, or
We haven't thought about that.
Yeah.
We could do something like that. Something I've been thinking. So I think like the actual like if you're gonna open source a plugin, like it should be in its own repo because like you want every make your like
but you also want connections to like all the infrastructure on XLA, right? So like the versioning, like all this other kind of stuff. So it's integrated as closely as possible. But it's also I don't know. There's
I mean if you can like upstream, because like the kind of XLA plugins like live in XLA trees. So like I think if you have like an XLA based plugin that makes sense to upstream, And another thing we sort of talked about too for like the user perspective is like right now JAX has like these like different like they're like pip like extra dependencies. Like you install like JAX CPU or GPU, and then what that literally translates to is like in our setup.py, there's like a string that's like GPU, and then it has like, we do call it CUDA. Yeah, that one we made the right call it CUDA. And
because we'd like to have a Rockman over there.
Yeah, no, at some point we realized that we actually got this one right. It's actually like, there's a version, it's like CUDA 12. But like, and then that pulls in like both the CUDA 12 plugin and like any other dependencies, like actually that type of stuff. And so we are super open to like when there's like, your plugin's in like good shape and you're like ready to actually get some usage, like we could add just like, a Rockham extra. Like so we could kind of like upstream like that special like install config. And then I think that's like a good like centralizing place. And like add it to like documentation so that like users all the support.
Right. And then maybe, so that's definitely what we want. And then the other thing is like where do we get the plugin? Where's the appropriate place? If there's a HiPi, or we could have our own applications, or I think there's today Google has the JAX, lots of different builds of JAX out on Google storage.
So that's another nice thing about the plugins is that like we sort of like needed to use like Google storage instead of HiPi because like we had like a million different packages called JAXLib and like they're different.
Exactly.
So with the plugins, we think that actually everything can live on HiPi, which is great because then users don't need to like use this index file to install. Very simple install. And yeah, and then like with this extras, it's like as long as you put your stuff on PyPy, then like you can use a repo or whatever, and like you have your own release mechanics and blah blah blah. Compatibility, that should be fine. As long as you release it often enough.
Yeah.
Or you can like, like pin dependencies, so pip sometimes can handle that or not. That might not work in that version. But then yeah, it's all like the setup.py can sort of like depend on whatever. So like, yeah, it gives a lot of flexibility for.
Okay, yeah, so that was my other question, like where should we target? PyPy is going to be the appropriate place.
Definitely, I think that's where users are most happy.
Yeah, make sure you get all the automation in place. You get the Jax does release very often. That's the other thing, right? At least it's to kind of come out very.
Well, so that's why we have like the API compatibility.
Yeah.
To try to give you some flexibility on how often you need to release in order to be compatible with the most recent Jax version. And then the other option, if you fall out of the window, which is fairly short right now, is like, yeah, unfortunately, I don't know if PyPy is going to handle like if it's like pip install Jax Rocco. Like, I'm not sure pip will be like, oh, there's not a Rocco that's like up to date enough. Like, I don't think it's a reverse dependency because it's dumb. But you can at least document like this is the max of like, yeah, like this is the max of Jax. We can play all this by ear.
Yeah.
Like, I'll be so happy when we get to the point to like debating exactly the distribution mechanism. Yeah, and I think we would be like happy to like put stuff in like the Jax screen made at home direct.
Yeah. Oh yeah, for sure. I will want that as well.
Awesome. I think it's lunchtime.
Yeah.
Great. Thanks so much, guys. Thank you.
So it'll be lunch until like 1 o'clock. Just hang out in Mariposa Grove and then we'll start the lab sessions from 1 to 4. Thank you.